Hi, in this video we're going to extend the deck of cards that we previously built and we will build a poker 5-card hand and um, analyze that hand so that we can compare different poker hands to each other and understand the frequency of various hands in poker. Now, most of you are probably really interested in Hold'em, Texas Hold'em, and that's not what this video is about. In a future video, I will probably, um, you know, make modifications to our structure in order to work with Texas Hold'em. But in this video, we're just going to focus on analyzing a 5-card poker hand, comparing two different poker hands, and correctly identifying the winner. Yeah, let's jump right into it. Before actually I move any further, the format of this video is going to be slightly different. I'm not actually going to type in the code as I go along. I've already typed in the code and I've committed it to GitHub. I'm going to explain the code and walk through the code in my IDE with you, and of course I'll provide links in the description box to all the resources, including the GitHub repository where the code exists for you to go off and download and modify as you see fit. Okay? And one more thing is that here I have this Wikipedia resource that talks about the poker probabilities for various hands, so we can use this as a point of reference when we finish our application to make sure that the probabilities that we find closely match those found here. And again, I will post this in the description box, but you can see here, for example, that a royal flush occurs approximately 0.00015% of the time, right? So we really want something to baseline and compare ourselves against. Okay, so having said that, let's jump right into it. Here I have the deck class that we built in a prior video, and I've made some very minor modifications here that you can choose to use. They're really there for convenience. I made the so what I did was I made the deck constructor private, and it takes this boolean should shuffle, and if should shuffle is set to true, we shuffle the deck. If it's not, we don't. We just return it in its natural ordering based on rank. And I have introduced this factory method called new shuffled single deck and also new unshuffled single deck. So the user of my API does not have to worry about this should shuffle boolean. They can just use one of these two public API methods in order to get a deck. I also introduced a size method on here to get the size of the deck. So that's the change that I made to the deck class. The new class that I introduced, there's two new classes that I introduced here. The main one is the 5-card poker hand here. And I want to, so the first thing that you'll notice is that 5-card poker hand implements comparable because we want to be able to compare two 5-card poker hands against one another. Okay? And so the first step is building a 5-card poker hand. Okay? And in order to understand how I've chosen to build a 5-card poker hand, we're going to go all the way to the bottom of this class file. Okay? And we're going to look at the builder that I introduced. If you're not familiar with what a builder is in Java, you need to read Joshua Bloch's Effective Java. That pattern is introduced in that book, or it's detailed in that book. It's not introduced for the first time in that book, but it's detailed in that book. And you can see here that I have this sort of static class with a mutable sorted set of cards member field, and I can add an optional card into the builder with this add card method. And if the card is an empty card, if that's what we return, then we get this illegal state exception. Otherwise, we get that card out of the optional and add it to our sorted set of cards. And then when we finally come to build the hand, we will check the size of our hand and make sure that it is 5, right? And if there are 5 cards in our hand, if there are not 5 cards in our hand, we throw a runtime exception. Otherwise, we will call the private constructor 5-card poker hand and with this, passing in this as the constructor, the builder in there. Right, so we'll go in here, and what you'll notice in the constructor here for 5-card poker hand is that we will construct this hand analyzer object, and we will also initialize this classification object. So let's first look at the hand analyzer. Okay, the hand analyzer is really just a small helper class, static helper class, that we're going to use in order to do some calculations that will help us downstream in quickly identifying a hand, conveniently and quickly identifying a hand as, say, a full house or a set or a pair or 2 pairs. And you're going to see some things in here that you might not have encountered that are new to Java 8, so I'll walk through each one of them. Okay, so the first thing that we do is we take our sorted cards and we maintain them in here in this hand analyzer object, right? So we've stored our cards, and then we invoke these little static helper methods called initRankGroup and initSuitGroup. Okay, so let's first take a look at the initSuitGroup. It's a little bit simpler, and you'll see what's happening here. And first, I want you to notice that the rank group and the suit group, what are they? They're just a map, right? One is a map that maps the rank to a list of cards, and another is a map that maps the suit to a list of cards, right? So, if we so the intention there is that, let's say we had 2 pairs. Our hand consisted of 2 pairs and a kicker. What we would really want here in the rank group is a way of saying that I have a map that gives me the rank of 1 pair and the cards associated with it, and the rank of the other pair and the cards associated with it, and the rank of the kicker and the single card associated with it within a list, right? And it would be ideal if there was some sorting done on the map so that we could conveniently retrieve these various different groups out. Okay, so first let's look at the easy version, the suit group. The suit group basically says, given the cards, right, let's call cards stream and collect, this is Java 8 syntax, and use the collector's group by and group the cards by their suit, right? So if we had a flush, and that means we'd only really have a map with 1 entry. The key would be the suit. Let's say it's a heart flush. That key would be the heart, right? Suit, and the list of cards would be all of the cards that have that particular suit, right? In the case of a flush, it's all of the cards. Okay? And finally, we take all of that and we put it in a tree map, and the tree map is what's going to allow us to sort by rank, right? So the entries of our map will be sorted. They will be sorted. So here you can see tree map. The constructor says constructs a new tree map containing the same mapping as the given map, ordered according to the natural order of its keys. Okay, so that's fairly straightforward, right? And that's what's going to happen here. Now, the other the rank group is going to be a little bit more complex. I would argue this is probably conceptually the most complex part of this whole program. Most hands, this is the most, this grouping result, this map of ranked cards is actually the most important data structure in the whole program. And effectively what we want to do is we want to take the cards that we're given, and first we want to sort the cards in the map sort of by two dimensions. The first dimension is the size of the cards in the rank group, right? So if we had a full house, I want the set inside of the full house, I want that to be in one group, and I want that to be sorted higher in the map of entries, right? I want that earlier in the map than the pair, okay? So this comparator says, hey, take this, compare the size of the values, the list of cards, right? And if they're equal, then I want you to use compare the ranks. Otherwise, use the size. Okay? And I think when we step through the code in the debugger, when analyzing a full house, we'll do that. You'll see what the map looks like after we do this. But I claim that after we do this, then we will not have to do a lot of the if-else logic in order to go out, for example, once the map is constructed and say, go find the set in this, in the map. Go find the pair. We know that the set will always come first, so we can say, hey, just get the next entry out of the map. That's going to be the set. And then if the sets that you're comparing for two full houses are equivalent, then we say, hey, go get the next thing out of the map, and that's going to be, by definition, the pair. And if those things are equivalent, then we would say, and by the way, for a full house, that would never happen, obviously, because you can't have two full houses tie that far. The sets will always differentiate. But for other hands, like two pair, that could be the case. So you want to do the comparisons all the way down, and that will make the comparisons really easy. Okay? So bear with me here. We'll see this again down the road, but we construct these two grouping operations, right? These two maps right here in the constructor, and then we count, hey, did you find any quads in the hand? Did you find any sets, or did you find any pairs? And if you did, let's count them up. So let's take a look at for example, how we do that. We have this group count method. It says how many group results do you want? That's the count, right? And we go in and we say, let's say we pass in 3, that would identify a set. We go through each of the map entries and we say, give me the one where the count is 3. And if you find it, return that. Increment matches and then return matches. For a 5-card poker hand, you'll never get for a set more than 1, obviously, right? So yeah, there you go. That's what that does. And then these are just sort of getter methods right here. The rest of these are getter methods. So hopefully that wasn't too difficult to understand. The hand analyzer, again, we're going to see this in the debugger, and I would argue this is the most important part. Once you have the hand analyzer worked out, everything else is easy. So let's see, what else do we have? We have the hand classification. Let's see how we classify hands. We come in here and we say, we use this telescoping if-else structure, right? And that's what really helps us identify, that also helps us really identify the hands. We go, do we have a royal flush? If not, then do we have a straight flush? And I actually separate out a straight flush that's a wheel, ace, 2, 3, 4, 5, from the other types of straight flushes. The reason I do that is because it reduces a lot of if-else logic that you would have to write when comparing straight flushes, because a wheel straight flush, the highest card is an ace, right? But it's actually playing in the position of the lowest card. It's playing as a 1, right? So I actually classify that slightly differently, and it doesn't matter. You can always collapse straight flush wheel and straight flush upstream in your code, but it just makes this API much simpler in order for me to separate them out. So let's take a look at what is an example of one of these, like is 4 of a kind. What does is 4 of a kind do? Is 4 of a kind basically says, hey, go to the hand analyzer, get the rank group, right, and get the entry set, iterate, get the next thing. And we know by virtue of the fact that I said that the maps are sorted that the next thing is going to be the most quote-unquote powerful part of the hand. So if we have a quads in our hand, then it's going to show up first out of the map. And then we're going to get the value, and the value is going to be the list of the cards, and we're going to ask, is the size of that equal to 4, right? That's it. And in fact, actually, I should update my code here. I'm not using, I'm glad I did this because you can see what it is, but all I need to do is to get the rank. I've already done the work here. I could just say get rank group this dot hand analyzer dot get quad count, and maybe I didn't write this method, quad count is equal to 1. Okay, so let's go to pair count. Let's write that method here. So int get quad count, return this dot quad count is, that's it. So we should have 1 quads if we found a quad in there. I'm glad I found that. Right. So let's take another example here. Let's look at is royal flush. Is royal flush is actually really simple because there's really all we have to do is flatten the cards out, and we know that the cards are sorted, and we can say, hey, is the first card a 10, the second card's rank a jack, the third card a queen, king, ace, you get that, right? And lastly, after we check all that, we want to make sure that the hand is a flush. Let's take a look at flush. Is flush. So what we say is that return the hand analyzer suit group size is equal to 1. We own, for all 5 cards, map to a single suit group, right? Very simple, okay? So you can walk through these in the GitHub and see how they work out. I would argue the more challenging ones are actually the lower hands. So let's take a look at 2 pair. For 2 pair, you know, just say, hey, is the 2 pair count equal to 2? Okay, actually that wasn't too bad. Let's see, is set counts equal to 1, right? So our data structure, the hand analyzer data structure, did all the heavy lifting when we did the group by operations that Java 8 introduces for us. Okay, so we come in here, we do this telescoping if else. If we pass through all of this, then we must the hand classification must be high card, and that's really that is a big portion of our program. Okay, now, so we've initialized those two member fields in our 5-card poker hand. Now, what if we want to compare 2 hands? Okay, so you saw that we overrode the we implemented the comparable interface, and so here's our override for the compare to method, and there's really only 2 scenarios that we need to consider. Okay, the first scenario is that the classification of the 2 hands that you're comparing is different. If it's different, then we want to return that difference. Okay, we're going to use integer.compare and compare the hand classification value. Okay, so the hand classification value is something that I've set explicitly in each of the hand classifications. So the royal flush has the highest value all the way down, right? So if you're comparing a full house to a flush, then the values will be different and you're done, right? You're done here. You'll say return classification comparisons not equal to 0, return it, and you're done. Otherwise, if you're comparing 2 hands that have the same classification, let's say it's you know, your first hand's 2 pairs and your second hand's 2 pairs, you're going to need to invoke this deep hand compare method and pass in both hands. Okay? So the deep hand compare method basically takes the first hand's hand classification and invokes an abstract method that I've written called tiebreaker and passes in those 2 hands. So if we go to the tiebreaker method, you'll see it's abstract and it's implemented for all of the enum values in our hand classification. So let's take a look at an example of one that is slightly more sophisticated. Let's take a look at, let's start with full house, actually. So with full house, we say return hand utility compare full houses. okay, or full house hands. We come in here and we pass in both hands. We come in here. First thing I do is I make sure that the hand classifications for both hands are indeed a full house, right? That's what this check classification method does. It just says, hey, if the hand's classification is not the classification that you pass in, then throw a runtime exception, okay? And then I get an iterator on the from my hand analyzer, right? So hand.getHandRank iterator. If we click in there, it just says this hand analyzer get rank group, that map, one of the two maps, the rank map group, entry set iterator. Okay? And again, because it's sorted in those two dimensions that we like, all we have to do, notice, is this. We say, to compare the sets in these two full houses, just go to the hand iterator and get the next key. And that, by definition, if this is a full house, you're going to get the rank of the set in your hand and compare it to the other hands. So if you have two hands where the sets are, if the sets in the two full houses are not equal to 0, okay, then return that set comparison. If they are equal to 0, then the next thing we want to do is compare the pairs. And if the pairs are not equal to 0, then you say, that's impossible. You return the runtime exception. And as I say this out loud, I'm realizing that this is a minor bug in my code. Actually, we could return the runtime exception right up here. Because in a 5-card poker hand, you can never have two hands dealt from the same deck where the sets are tied. You could in Hold'em poker. So this method right here is actually complete for Hold'em poker. It's slightly incorrect for 5-card poker. So you can look at the GitHub, and if you want to make that modification on the fly, you can. You don't have to. So it doesn't really matter. It's not effectively. It doesn't really effectively matter. So let's take a look at. Let's take a look at one more tiebreaker, 2 pairs. How do we do a tiebreaker for 2 pairs? Right, again, we make sure that, in the hand utility method, we have this compare 2 hands method. We make sure that both hands are 2 pairs. We get the iterators again, the rank iterator, right? And we basically go through and we say high pair comparison. How do I know I'm getting the high pair comparison? By definition, because the rank map is sorted, all I have to do is say hand iterator, next key, get the rank value. Compare it to the other hand's iterators, next key. Okay? If that's not equal to 0, that means the ranks are different. Return the high pair comparison. If it is equal to 0, I need to do the low pair comparison. And here's where I would want you to pause and think. How would you, if you don't do what I did, how would you go through and find the high pair and the low pair in a poker 2-pair hand? You would have to do a lot of work and say, oh, get the max of the pairs out of these hands. It's just a lot of work. But because we set the data structure up correctly, we don't have to worry about it. We just say, get me the next thing from the iterator. And if the low pair comparisons are not equal, return it. Otherwise, if those are equal, right, if you have 2 poker hands where the high pair that are both 2 pairs and the high pairs are equal and the low pairs are equal, completely possible, then you have to look at the kickers. Okay? So return iterate and compare high card. That's what that does. It takes the iterators and it basically says, hey, while the hand iterator has next, really there should only be one thing left in the iterator at this point. All you do is you just say get the next thing and compare it. And if it's not equal to 0, return it. Otherwise, at the end of here, you get a tie. And I use this iterate and compare in a couple of other methods. Like for example, when you're comparing 2 hands that are both just high cards, you actually go ahead and iterate through all 5 cards to compare them, the high card. So hopefully that makes sense. So this was a little bit dense, right? I mean, it's not a lot of code. The hand utils method, which contains each of these helper methods for the tiebreaker, it's about 200 lines of code. The 5-card poker hand is approximately let's say 350 lines of code. And we have a main method, and I'll go over that in a minute, and we have our deck that we wrote previously and card. One final point that I want to make before I go to main is that I did modify the card from what you guys had. I introduced the hash code and equals method on a card so that I can have so that it really makes sense for my sorted set, right? So we have this hash code and equals. I use the IDE to generate these methods. If you don't know how to do that, you can look it up on the internet. It's really simple. But you can have your IDE that will generate hash code and equals. I won't go over what those methods do. If you don't know, you really need to pause the video now and go off and research what that means. Of course, it also means if you're not familiar with what a sorted set is, you should really pause this video and figure that out too in order to understand this. So let's look at my main method. My main method runs 2 experiments. Okay, I have 2 private methods that are my experiments. The first method is ideal. I use Java 8's ranging methodology to basically run 5 million, 5 million experiments, and I'll deal 5 cards out, build a hand, right? And I'll do the classification, and I will I have this frequency table object that will use the ordinal on the classification in order to tell me what the different classifications are. You'll see the output. I'll explain the output in a second. The second experiment that I do is I create 2 hands. So I deal these cards. Here's one hand that I build and another hand that I build called hand 2, and I simply compare hand 1 to hand 2. I run that experiment 5 million times, and I find out how many times did hand 1 win, how many times was it a tie, and then how many times did hand 2 win. And of course, if none of those is the outcome, then I just throw a runtime exception, WTF. Okay, so let's run this experiment. It takes, with 5 million instances, it takes some time. So why don't we run it with 1 million instances? It shouldn't take that long with 1 million instances. So let's maximize our screen here. First experiment's about done. So yeah, and then now the second experiment's done. So let's look. So the first thing that I want to call your attention to is that in this array, this frequency table array in the first experiment, this bucket is a royal flush. This is the straight flush as a straight flush, and then the straight flush is a wheel, 4 of a kind, all the way down to high card, right? So let's just do one simple experiment. Let's bring up a calculator and say we got 2 outcomes that were a royal flush divided by the 1 million experiments that we ran, which is 0.000002. Multiply that by 100 and you get 0.0002. And if you look at this table, the probability is 0.00015. So the more experiments that you conduct, you'll find that you approach that true probability. That's known as the central theory of probability, by the way, right? So with 1 million experiments, you got kind of close to that. With 10 million experiments, you'll get even closer. With 100 million experiments, it'll look pretty much, it'll match pretty much the probability that's listed on the Wikipedia page. Let's take one more example here. 221 is the 1, 2, 3, 4th. So let's take a look at let's go here, look at the ordinal for the hand classification. You got, let's see, the 4th one off the top, or would be 1, 2, 3, 4, 4 of a kind, right? So 1, 2, 3, 4, 221 4 of a kinds. 4 of a kind shows up at 0.02%. Right, so let's clear that out and say, oops, 221 divided by 1 million times 100, 0.0221, right? So that's pretty close, actually. So you can go through that with all of these. That's the nature of our first experiment there. Okay? The second experiment actually compares hands, and what we find is that the first player won about 500,000 times, the second player won close to 500,000 times, and there were only 111 ties in the entire 1 million deal experiment. Okay, so that's what we've done here. I think what I want to do in the future videos, I want to build off of this, make modifications to do other cool experiments, maybe around Texas Hold'em. You guys can leave feedback in the comment section for what you would like to see. Hopefully this format worked for you. If I didn't use this format, it would have taken me a really long time to make this video, and I want to respect everyone's time here. So please do make sure to rate, comment, and like the videos. It makes a big difference. And as always, please subscribe. I'll try to come out with new content fairly regularly. Okay, thanks for your time.